All right, let's use the function f of x equals 1 over 1 divided by x plus 1 for these three problems. And again, we're going to use the definition of the derivative. So f prime of x is equal to the limit as h approaches 0 of 1 divided by x plus h plus 1 minus 1 divided by x plus 1 all over h. Again, we're going to need a common denominator. So we're going to multiply the first fraction, the numerator and denominator, by x plus 1. And then we're going to multiply the second one by x plus h plus 1. Right, so we have the limit as h approaches 0. So we have x plus 1 and then minus x plus h plus 1. And then just put it over one denominator because we want to be able to simplify and combine things anyway. X plus h plus 1 times x plus 1 all over h. All right, let's distribute the negative. So we have the limit as h approaches 0 of x plus 1 minus x minus h minus 1 divided by x plus h, x plus h plus 1 times x plus 1. Right, and then we'll combine, we'll be able to cancel out some things. So the x's will cancel, the 1's will cancel. So we just have a negative h left. Oops, I almost forgot. You know, I'll just put it over like this, 1 times 1 over h. Because in the next step, I want to be able to do that anyway so that I can cancel out the h. So we have negative h divided by x plus h plus 1 times x plus 1 times 1 over h. And so these h's will cancel. And so the derivative, so our limit here is h. The limit as h approaches 0 is negative 1 divided by x plus h plus 1 times x plus 1. Now we can plug in the 0 at this point. Because we're done simplifying, it's no longer indeterminate. So we have negative 1 divided by x plus 0 plus 1 times x plus 1. Well, that's really x plus 1 times x plus 1. So the derivative for this function is negative 1 divided by x plus 1 squared. And there we go, we have it. All right, so now let's write the equation of the tangent line drawn to the graph of f of x at x equals 0. All right, so we need two things to write the equation of a tangent line. We need the slope and we need a point. All right, so to find the slope, we're going to plug into the derivative. So we have negative, and actually we're going to plug in at 0. So let's write in 0. So f prime of 0 is 1 divided by 0 plus 1 squared. Well, that's going to be 1 over 1, and that's just 1. Right? So the slope is 1. The point, we plug into the original equation. So that's going to be f of 0, which is 1 over 0 plus 1. Well, that's 1, too. So the point here is 0, 1. And you know, let me fix that. There's no reason to even use point slope because we have the y-intercept. So why not just put in y into slope-intercept form? So y equals x plus 1. There we go. There's the equation of the tangent line at x equals 0. We want to find the equation of the normal line at x equals 0. Now the point is going to be exactly the same. That's not going to change. So 0, 1's the point. The slope, so the tangent line, is perpendicular to the normal line. So that means the slope for the normal line will be negative 1, the negative reciprocal. In the case of 1, though, the reciprocal of 1 is 1. And we just change the sign. So the equation is going to be y equals negative x plus 1. And there we go. So that was not too bad at all. Okay? Especially writing the equations of those lines. Look at that, 4 minutes. We got the whole problem done. All right, so understanding the derivative from a graphical and numerical approach. And these should all be in your notes. We're going to do a few more with graphs, and then in the next lesson, I'm going to do even more with graphs. So far, our understanding of the derivative is that it represents the slope of the tangent line drawn to the curve at a point. Complete the table below, estimating the value of f prime of x at the indicated x values by drawing a tangent line and estimating its slope. All right, so we have to kind of estimate the easy one. And by the way, this is on 2 pages because I couldn't fit it all on 1 page and have it be readable. So the easy one, let's do the easy one first. So I already drew in the tangent lines, and all you do is you just try to hug the function. You try to follow the function and go through the point. Right? So, and you have to kind of just do the best you can. So the easy one to figure out is right there, slope of 0 at 1, 2, 3, 4, negative 4. So the estimation of the derivative, f prime of negative 4 is approximately 0. That was the easy one. All right, let's find all of the slopes, and then we'll talk about increasing, decreasing, or the relative max or relative min, and then we'll talk about the equations of the tangent line. All right, so we got that one. Now let's look. Now we just got to look at the others. All right, so the at negative 7 it is positive, and let's see. I would say it goes up 1, 2, 3. I'd say it's going up 3 to the right 1. So I'd say that's about a slope of 3. So at 7, f prime of negative 7 is approximately 3. Now it's not as steep at x equals negative 6. Let's see, it goes, I'd say it's about 2. All right, this looks kind of going up 2 to the right 2, or to the right 1. So f prime of negative 6 is about 2. And then we just need f prime of negative 2. That one has a negative slope. It looks less steep than in the other direction, but it looks less steep than at negative 6. It looks like it's going down 1 to the right 1. I'd say that's a slope of negative 1. So f prime of negative 2 is about negative 1. Now, is the function increasing, decreasing, relative max, or relative min? All right, so let's put this right in our notes. All right, so f of x is increasing when f prime of x is positive. And f of x is decreasing when f prime of x is negative. All right, so let's go through the positive and negative values, and we can write in increasing and decreasing, and we will put a little explanation. Always put an explanation. You're much err on the side of putting an explanation in at all times. All right, so f prime of negative 7 was approximately 3. So here, f of x is increasing. And this is the symbol for because f prime of x is greater than 0. Right? We can say it nice and succinctly. The same is true at negative 6. F of x is increasing because f prime, I should really say, be a little bit more specific there, I'm sorry. F prime of negative 7 is less than 0. So f of x is, I'm just going to erase that. I'll never get it back in. F of x is increasing because f prime of negative 6 is greater than 0. We got to be a little bit more specific. Let's skip over the purple one for right now. Let's go to the green at negative 2. So there, f of x is decreasing because f prime of negative 2 is less than 0. Now let's talk about what happens when it's at 0. All right, so that's where our relative max and min values can occur. Let's put this up here, I guess. All right, so relative extrema can occur only where f prime of x equals 0. All right, so our relative max and min values can only occur when f prime of x is 0. And that doesn't mean that every time f prime of x is 0, that every time the slope is 0, it's going to be a relative maximum. Right? It could have a tangent line of 0 and then keep on increasing after that. All right, so we have to look at what's happening on either side to know whether it is a relative extrema, and is it a relative maximum or a relative minimum. All right, so here at 0, f prime of x changes from positive to negative, from increasing to decreasing. And we know that when a graph of a function changes from increasing to decreasing, it has a relative maximum. So when the derivative changes from positive to negative, in other words, the function is changing from increasing to decreasing, right, that's going to be a relative maximum. So at x equals negative 4, there's a relative maximum. Let's abbreviate relative. Relative maximum. And I better put a symbol in for because. Trying to figure out how to fit everything in little boxes. Because f prime of x changes sign, and we'll go over this more in the next couple lessons, from positive to negative. Right? So that's going to be a relative maximum. Right? Because our function is changing from increasing to decreasing, the derivative is changing from positive to negative. All right, let's write the equations of the tangent lines for the various values of x. Remember, all you need to write the equation of a line, you need two things. You need slope. Right? So f prime of x, that's going to give us our slope. And f of x, that'll give us our point. And we can just look at the graph, which is good because we don't have an equation. All right, so the slope we said was 3. And the point, so if we go to negative 7, that is negative 7, negative 3. So the point is negative 7, negative 3. And we're going to leave these in slope in point slope form because there's just not a lot of space. So y plus 7 equals 3 times x. Excuse me. One of us is reading our values backwards. Y plus 3 equals 3 times x plus 7. That's fine. We'll leave it in point slope form. Oh, I hate it when my throat gets dry. Happens whenever I'm talking a lot. All right, let's look at the next one. And we'll write the equation of the tangent line. Well, I try to grab some water. All right, so again, we need the point. So sorry for that. We need the point and we need the slope. And of course, we have the slope already. We estimated that from the graph. So the slope is 2. And the point, let's look at the graph. All right, so that's going to be negative 6, 0. That was pretty easy. Right? So we don't really need to write y minus 0, do we? So y equals 2 times x plus 6. Right? If you want, you can put y minus 0. But that's fine. Or if you want, you can put y equals 2x plus 12. Right? Those are all good equations. Right? We don't have to be so picky about necessarily putting it in perfect, exact slope-intercept form. Right? Any equation of the line is good. Point slope or modified point slope. Right? So let's look at the next one. All right, the next one's really, really easy because it has a slope of 0. And the point there is 1, 2, 3, 4. So 4. Oh yeah, it was 4. 4. Negative 4, 2. We know it's negative 4. What's the y value? So the point is negative 4, 2. All right, so the equation of a horizontal line is just y equals whatever the y-intercept is. Right? So if we continue that line, of course, it would intersect the y-axis at 2. So this is the equation y equals 2. And then the last one on this page. All right, so we need the slope. Actually, let me abbreviate that, which is negative 1. And then the point is negative 1. We're not negative 2. Negative 1, negative 2. Negative 2, 1. Looking at the wrong point there. Negative 2, 1. All right, so this is going to be y minus 1 equals negative 1 times x plus 2. And that's perfectly good. Right, so there we've done these 4. So I hope this is really starting to bring the derivative to life, right? Helping you understand what the derivative actually means and what it tells us. It tells us a lot. We've only just begun interpreting the derivative. Same graph. Now we're just on the other numbers. All right, so negative 1. Right, is over here, and that seems to be going, I'd say that's going down 3 to the right 1, so I'd say that's a slope of negative 3. Oh, we lost what it said on the top of the table, so let's write that in. So as a reminder, it said estimation of derivative. Actually, we'll just fill in one line at a time. So this is estimation of derivative. Okay. All right, so f prime of negative 1 was about negative 3. All right, so then moving along, next one is pretty easy at 1. Slope is 0. So f prime of 1 is approximately 0, though I feel pretty confident that that's 0. And then the green one there at 3, let's see. Looks like it's going maybe up 2 to the right 1. Let's call it 2. So f prime of 3 is approximately 2. At 5, that's another easy one. Let me switch colors. All right, so slope is 0. So f prime of 5 is 0. And then 7, right, pretty steep line there. I'd say it's even steeper than negative 3. Let's call that negative 4. That looks like it might be about negative 4. So f prime of 7 is approximately negative 4. All right, so then the next column said increasing, decreasing, max or min. We'll just abbreviate. right? And you don't have to do that because yours is all on one page. All right, so the next one, all right, so it's negative, right? So f of x, the derivative is negative, so f of x is decreasing. And we know that because f prime of negative 1 is less than 0. Let's fill in all the ones that aren't 0. And so let's fill in f of 3. All right, so notice f prime of 3 is 2. That's a positive number. So f of x is increasing because f prime of 3 is greater than 0. And then the last one there that's not a 0, right? Notice that f prime of 7 is a negative number, so that means f of x is decreasing because f prime of 7 is less than 0. All right, now let's look at the values where the derivative is 0. Now, those are candidates to be a relative max or min. All right, to be a relative max, you're going to change from positive to negative. So f of x has to change from increasing to decreasing. F prime of x has to change from positive to negative. To be a relative min, f of x has to change from decreasing to increasing. F prime of x has to change from negative to positive. So let's see, at 1, right? So if we look at the graph, f of x was decreasing, f prime of x was negative, and then f of x is increasing, f prime of x is positive. So this is a relative min because f prime of x changes sign. I don't know why I didn't put the abbreviation for because there, but all right. Oh well. Changes sign from negative to positive. We have to abbreviate as much as we can. And now look at the second one there. Second candidate to be a relative extreme of value. All right, so now f of x is increasing to the left of x equals 5 and decreasing to the right of x equals 5. And notice that the derivative changes. So to the left of x equals 5, the derivative is positive. And then to the right of x equals 5, the derivative is negative. Right? So the function is changing from increasing to decreasing. The derivative is changing from positive to negative. Right? This is a relative maximum. So this is a relative max because f prime, oh, and I should have put, I did it again, huh? I forgot to put the number in there. Relative min because f prime, well, it's not really 1 changing. You know what, let me just kind of let's keep it as f of x. I'm trying to get my sentence just so, and just so little space. Let's keep it as f of x, changes sign from negative to positive, and we'll have to understand that it's at x equals 1, right? I can't squeeze that in. I just can't. I can try, but I just can't get it in. The same thing here. So normally we would put relative max because f prime of x changes. And normally I would write out positive and negative and not use symbols, but there's just no space. Changes sign from positive to negative. And it's just going to have to be understood at x equals 5 because we don't have any more space. Maybe you could squeeze more in than I can. All right, and then the last part here is the equation of the tangent line. All right, and so of course we need a slope and we need a point. So on the first one, the slope is negative 3, and if we look at x equals negative 3, the point is negative 1. So that'll be y plus 1 equals negative 3 times x plus 1. We're leaving these in point slope form. All right, now let's look to the next one. All right, so that's at 1, 4. All right, but it's a horizontal line. All right, so it's just going to be the slope. The equation is just going to be y equals 4. All right, maybe we'll put the point and the slope in just to be consistent. Oops. There we go. There's the equation. All right, so now let's look at the next one. All right, so that point is 3, negative 1. The slope is 2. Sorry, my shadow's blocking. The point is 3, negative 1. So this will be y plus 1 equals 2 times x minus 3. The next one, I'm trying to color code it. Of course, now I know with a bunch of orange dots. Slope is 0, so m equals 0. The point, that is 5, 4. So the equation is going to be y equals 4. Oops. I hate to use the eraser because then I have to get the pen color out again. There we go. And then the last one, slope is negative 4. The point is 7, negative 1. So this will be y plus 1 equals negative 4 times x minus 7. And there we go. All right, we've approximated the derivative. We've learned a little bit about increasing, decreasing, relative max and min, and we've written the equations of the tangent line. All right, so we've made some good ground here. All right, so I have this filled in for you. You can just add it to your notes. Based on what you observed in the table on the previous page, what inferences can you make about the value of the derivative f prime of x and the behavior of the graph of the function? So when f prime of x is greater than 0, f of x is increasing. We already wrote this in pretty much. But if there's some space here, you might want to just write it again just to make sure it's clear. Where f prime of x is less than 0, f of x is decreasing. Where f prime of x is 0, it is a possible relative maximum or relative minimum value. So the values of f prime of x give slopes of the tangent line for a given x. Right? So that is a key idea, a big key idea. And I'm going to start this one on the next video. All right? So thanks for watching. I'll see you in the next video where I'm going to finish this part 1 up. All right? Bye for now.